My name is Jasmine, and I'll be talking about section 9.1 today. Okay, so now we're going to talk about points and lines. So we have points, planes, lines, and collinears. So with points, it usually looks like something around this. That would be called point A. So it's like a little decimal or a period with a capital letter following behind it, and that's usually how those are written. A plane can be like a little shape, like a little X right there. That would be called plane X. So far we have points A and plane X. And so then we have lines. And so with the lines, you have 2 points going in different directions. So that'll be called line AB. Then you can have line BA. They always look like this. So you got point A, plane X, line AB. So then you have a collinear line. And that can be written like this. So you have X, Y, and Z. The collinear line is just 3 points on the same line. For example, if you were to have a triangle that looks like this and have that label X, Y, and Z, that would not be a collinear line. Even though we did not pick up the pencil once, it is not in the form of a straight line. So it has to be like this. Okay, so now we're moving on to concurrent lines. If there is a point B that is on each of the lines, I, J, and K, then 3 lines are said to be concurrent. So let's say we have a line A, I, line J, and line K. So if there is a point B that is on each of those 3 lines, so if it has to touch all 3, that is where it intersects, then that means that these lines are concurrent. So with that being said, concurrent lines, and they intersect at point B. So next we're moving on to transversal lines. F, R, and S are distant lines, and T is a line that intersects each of them, but not at the same point. Then T is called a transversal to R and S. So let's just draw it out. We have line R, and then we have line S. So before we were doing concurrent lines, they touched at the same point when they intersected. But here, that's not the case. It says intersect each of them, but not at the same point. So they will not be at the same point. T goes through both of them, intersects right there at 2 different points. So T will be transversal to R and S. Okay, so now I'm moving on to line segments and the distance between points. So distance and absolute value have something in common because you cannot have a negative distance, so it will always be positive. Therefore, distance and absolute value are connecting when they're dealing with each other. So this will be a line segment. You have a starting point, you have an ending point. It is not continuing forever. It is not a line. This is not a line segment, but that is a line segment. So this will be called line segment AB or line segment BA. It will not be called line AB, line BA. That is when you have a regular line. So let's say AB is equal to the absolute value of -3 minus 7. You'll get a negative number when you do that. So you'll get absolute value of -10 But when you take the absolute value of the negative number, you get a positive number. So the distance will be 10. That is always why I use absolute value when you're dealing with distance. So the number does not come out negative, but it comes out positive. Okay, so let's go over a congruent midpoint real fast. So let's say we have a line segment of A and B. So we can mark this up to make it look like that, to where it is somewhat even. So the middle of this line will probably be right here, and we can say that is point M. So with that being said, line segment AM and line segment MB are congruent. The congruent midpoint will be M, which is making line segment AM equal to line segment MB. Okay, so now moving on, we have rays, angles, and angle measures. So a ray is a point pointing in one direction. So let's say we have, starting off as it being like a line segment, ended in like it's a line. Point A all the way pointing to direction B. So that is what we call a ray. And then you'll just write it as ray AB. So if you add another ray, that will make that an angle, and the endpoint being the vertex. So let's say we have point A, make that a ray to point B, make this another ray to point C. That will be in the angle, actually an acute angle, which we'll learn about later on since it's less than 90 degrees. So to write out that angle, you'll just write angle BAC, or you can also do angle CAB. So now, since we were talking about angles, the interior is the inside of the angle, which is here, and the exterior, which will be the outside of the angle, which is out here. Okay, so now we're moving on to some angle measures. So straight angle is 80 degrees. The straight angle will look just like a straight line, and that is 180 degrees. A right angle is 90 degrees, which will look like an L. It can be any way as long as you have that 90-degree angle. And so that's a right angle. And then an obtuse angle is greater than 90 degrees, but less than 180. So it can't be as flat as 180, and it can't be smaller than 90. So it can be 175, anything from 91 to 179 is an obtuse angle. So let's just say this is about 155. That will be an obtuse angle. And then last but not least, we have an acute angle, which is less than 90. More than 0, less than 90. So anything 89 and under will be an acute angle. So let's just say this is 40 degrees, and that will be an acute angle. So we got Q, obtuse. Okay, so with congruent angles, two angles are only congruent if and only if they have the same measure. So to break it down, let's say angle P is congruent to Q, or angle Q, and that is if and only if the measure of angle P is equal to the measure of angle Q. And that is how you have two congruent angles. So now moving on, we're talking about pairs of angles. We have complementary and supplementary to start off with. So complementary angles mean any two angles that sums up to be 90 degrees. That can be 40 degrees plus 50 degrees, or it can be 70 degrees plus 20 degrees. It doesn't matter as long as it sums up to be 90 degrees. So moving on to supplementary, you have two angles that add up to give you 180 degrees. That can be 50 degrees and 130 degrees, or 107 degrees and 10 degrees, as long as the supplementary angles add up to be 180 degrees. Okay, so now moving on to adjacent angles, you have two angles in the same plane that share a common side. So angle A, B, and C is one angle, and that shares a common side with angle CAD. So that right there will be adjacent. And then you have vertical angles. So vertical angles is just two intersected lines. So just intersect the lines, and then you have vertical angles. 1, 2, 3, 4. Okay, so now we have a theorem of vertical angles. So vertical angles are said to have the same measures, which is true. So let's say that this is measure angle X, and then this would make this 180 minus the measure of angle X, simply because this is a straight line right here, and you would just subtract that obtuse angle from that 180 degree. So, or subtract this acute angle from that 180 degree to get this obtuse angle. But whatever this would be, that will make this the same answer as well. And then moving down to corresponding angles, you have all these angles that are corresponding. So even though they're not vertically or directly beside each other, you can still tell which ones will be. So number 1 and number 5 are corresponding since they will be in the same spot. Number 2 and number 6. Number 3 and number 7. And number 4 and number 8. You can tell that these angles are in the same positions, are in the same measures, and those are how you tell corresponding and vertical angles measures. Okay, so corresponding angles properties. So two parallel lines are cut by a transversal line, then their corresponding angles have the same measures, which is what we just went over. So if they are cut by the transversal line, the corresponding angles, then that means the two lines that have been cut are parallel. So that will make these lines parallel to the transversal line. Okay, so let's put some of these properties into action. So let's say that angle 6 was the only angle that we were given, and that is 35 degrees. So knowing how we did with the vertical property, we know that 35 degrees for angle 6 is the same as 35 degrees for angle 8. So now we know that since this is a total of 180, that makes a straight line. We just subtract 180 from 35 to find out this obtuse angle right here, which gives you 145 degrees. And that will be for these two angles, since they're vertical from each other. And now we just do the corresponding property. So since these two are 145, that makes these two angles 145 degrees. And since these two were 35 degrees, that makes these two angles 35 degrees. So everything is just simpler when you know the properties, and it just makes everything way more smooth. Okay, so now moving on to alternate interior angles. So earlier we were talking about how if two lines were cut by a transversal line and had congruent measures, that means that the two lines were parallel. So that is the case when they have the same alternate interior angles. So let's say we drew this out, and angle 1 and angle 2 have the same measure. That makes these two lines parallel. So that is what we're meaning what we were going over that earlier. Okay, so now we're going to be talking about measures of a triangle. So we all know that triangles have to equal to 180 degrees. So this is angle 1, this is angle 2, and this is angle 3. Measure angle 1, measure angle 2, and measure angle 3 have to all equal to 180 degrees. It doesn't matter what numbers they are, but they all have to equal to 180 degrees. Any three of the angles of the triangle. With doing this, you can still add the exterior of it. And then these two angles will still be congruent, and these two angles will still be congruent. And it still won't matter because any three angles that you add in the triangle have to equal 180 degrees. It doesn't matter where the angles are. They have to equal 180 degrees. So moving on to exterior angles. Obviously, this is 180 degrees right here on this straight line. These two angles will have to equal 180. So measure angle 3 and measure angle 4 equals 180. All the interior angles have to equal 180. And so you find out that the sum of the exterior angles is the sum of the two angles that's not adjacent. So in this example, measure angle 1 and measure angle 2 will have to equal to measure angle 4.